It's the Life Upfront Engineering Podcast. I'm your host, Jeff Waters, covering ideas, people, and products on the cutting edge of product development. As always, join the conversation at lifeupfront.com. On the show today, a man who spent 17 years with PTC, eventually becoming VP Desktop Applications, only to leave for a startup CAE company with absolutely no interest in desktop applications. John Buchowski, VP Product Management for Ciespace. Welcome to the show.
Thanks for the intro, Jeff. I'm glad to be here.
Well, before we go any further, I want to make sure I get your name right. I've been pronouncing it like the trashy poet himself, Charles Buchowski, but I recently heard someone else pronounce it differently. What do you go by?
Never heard him described as trashy. I always thought it was beatnik. But anyways, I'm just like a dog. You can say my name however you want, and I'll still respond. So Buchowski, Buchowski. Unfortunately, I don't have a nice, simple, clean English or Irish name like Coleman or Smith, but it's the one I've got.
Fair enough. All right. Well, I gave a pretty broad stroke of your professional history there, but could you, before we get into Ciespace, give us a little bit more of your path to Ciespace through PTC?
Absolutely. So I got my start over with desktop. I've spent, at this point, I'm afraid to say, but it's been quite a few years working kind of specifically with engineering applications in one form or another. I got my start at PTC when I was working towards a master's in aerospace engineering at good old University of Minnesota, go Golden Gophers. And at the time, I was already using parametric CAD, designing experimental apparatus for wind tunnels, stings and so forth. Went in for, on a whim, went in for an interview. By the time I got back to my apartment, there was a job offer on the answering machine, and that's how it started. I always thought I'll go back to school someday, and I've just been a little bit too busy. So I started PTC working in the field. I was a sales engineer for a few years. Then I became a benchmark engineer, and then ultimately went from that actually to being a sales rep. So I joined the dark side out of engineering for a brief spell. Quickly came to realize what I value and realized that being more on the creation and helping solve problem side more than purely the selling side was really where my passions lay. So after a few years in sales, I actually moved in, kind of took a big step backwards in terms of personal finances, but moved into product management out of sales. But I've been very happy for it. And then worked my way at PTC up in the product management area from being responsible for just a few of our products in the CAE space to our desktop CAD products to ultimately being responsible for well north of $500 million of desktop engineering software revenue at PTC.
And that leads us to moving away from the desktop. So tell us about Ciespace, what attracted you to Ciespace, and let's start there, and then we'll come back to what exactly it is.
Absolutely. So, I think the only constant in the world is the fact that there is change. I always kind of got a kick out of the irony of that. But especially at PTC, I saw the power of change in a market and what that can do to the fortunes of a company, especially if it's able to adapt. And so we saw it work both ways at PTC in our favor and as a significant headwind. When the late 90s came about and the first kind of compute revolution, that hit the current generation of desktop engineering products hit, we saw what happened to companies like PTC and computer vision and so forth as companies moved from Unix workstations to PCs and desktop PCs. My belief is that we're seeing at least the same, but actually I personally believe it's more significant paradigm shift taking place now as we move from PCs to cloud. I think whether people admit it or not, this change is afoot, and it's going to change how we do our work. And so, I wanted to be at the leading edge of this change because I've been at the back end of it before, and I definitely want to be, I don't want to be following it, but I want to be leading it. And then I had a secondary personal goal of being at a startup before I turned 40. I missed that time frame by 1 year, but I'm glad to have at least made it. And then finally, I thought what Ciespace was working on was, it's pretty near to my heart, and it was pretty compelling. So those are some of the reasons why I came over.
So let's talk about Ciespace. What is it?
What is Ciespace? So you want to talk about the company a little bit, or the products, or how do you want to take this, Jeff?
Yeah, let's start with the products, and then we'll switch to the company and maybe get a little bit of history on the company. But in short, what is Ciespace all about?
So Ciespace is all about, fundamentally the very center of our DNA is we want to change how engineering applications are delivered and consumed by engineers, and we want to change it for the better. We think there's a massive opportunity being presented to us by the move towards SaaS and by the fact that SaaS is finally becoming a viable alternative. I think SaaS for engineering has been around for a while, but it hasn't really been something that's terribly viable. And I think that's really just now reaching an inflection point.
Let me throw out a definition real quick. I am sure that many of my listeners aren't really familiar with that term. So it's just software as a service, SaaS.
Yep, absolutely. So SaaS implies any software that basically it's pure SaaS is something that you can go to any web browser, log into a site or an application through that web browser and use it with no plugins, no downloads, anything like that. So imagine, for instance, Gmail is a great application of a SaaS mail application as opposed to, let's say, Outlook, which you would install locally.
And typically it's purchased on some sort of a variable period, if it is purchased, or, the desktop version is typically purchased outright. So you're paying a lot more upfront versus a typical cloud SaaS product where maybe it's a monthly charge or a usage charge.
Yeah, with SaaS applications, typically you're paying for what you use, and with desktop applications, you're either buying a perpetual license where you're paying annual maintenance on it, whether you use it or not, or you're buying annual licenses that you're repurchasing the application every year.
Okay. Well, so we have been hearing a lot about SaaS-based, cloud-based CAE products. Autodesk is doing a lot of work in that front. I think they are one of the, they're holding a leadership position in that. Let's put it that way. They're one of the first to really push it. But a lot of companies are starting to edge towards that. So what is special about Ciespace? Why? What differentiates you from the others, and what's your mission in this cloud SaaS CAE world?
Okay, so you just asked a question that we could spend a whole podcast on.
I typically throw out at least once about 8 questions at once, and then just see which one you answer.
I know. I was just thinking. I wish I was at home so I could crack open a beer, kick back, and start answering this one, because it would take at least 1 or 2 to get through. So, and I don't drink that fast. So, what makes Ciespace different? So, there's a few different things. The first thing that makes Ciespace different is that Ciespace is a SaaS provider. Basically, we talk, engineering software in the cloud or through the browser provider. That's one of the first that's a pure SaaS application. What I mean by that is that we really wrote Ciespace from the ground up to be a cloud delivered or a browser based application. So even when you use tools like GoToWebinar or some of these others, you still have to do a plugin or a download that gets installed in your browser. With Ciespace, there's none of that. It's really just put in, log in with your username and password, and you're off to the races. So one of the big differentiators is the fact that we're a native SaaS application. A lot of the other vendors that are moving to the cloud have, frankly, it's a little bit of a benefit and a little bit of a curse that they have legacy applications that they're trying to repurpose into the cloud. And so what they're doing, if you look at companies like you had mentioned, Autodesk, is they're doing great work and working hard at taking their existing legacy portfolio of applications and reposting them to the cloud. And the problem with that is that unfortunately that one, they have to support the capabilities they did previously, so that kind of hinders them a little bit. And 2, it does result that you have to have oftentimes a significant installation still on your desktop in addition to some of the capabilities that you can access from the cloud. We're able to use a clean sheet approach that gives us quite a few benefits. And then really another aspect that's fundamentally different about the Ciespace approach from the other applications is that versus a lot of the other vendors, their end goal is to provide their applications through the cloud. And our end goal is actually to be a platform provider for CAE applications in the cloud. So we see our end-to-end CFD application that we launched earlier this year and is already being used by commercial customers since March. That's kind of a one step on the road for us, but for a lot of other vendors, that's their ultimate goal.
That's a really good point. So you ultimately are an engineering CAE platform. It just happens to be that the first product you offered on your platform or the first solution is a CFD tool. And that CFD tool is based on Openfoam too. So that's an open source, probably the most well-known open source CFD product out there.
Yeah, it's pretty amazing. If you look at kind of open source applications in the engineering space, not a lot of people know that behind the tools from ANSYS and CD Adapco, Openfoam is the most widely used CFD solution. I think that's pretty much an anomaly in the engineering space. If you look at some of the other spaces, like for instance marketing or even for instance customer relationship management software, CRM, there's tools like Sugar and Git and so forth, Altation, that have been used quite extensively, even though they're open source tools. So Openfoam is a rare bird in the engineering space.
All right, so you've created this platform. You've got your first solution on the platform based on Openfoam. But let's go back into the history of the company. I think there's an interesting story about Dr. Shimada. It didn't start out as a CAE in the cloud platform company.
No, that's right. Just like when you look at the histories of most companies, especially startups, you'll see that they make a few shifts. We call these in the parlance, we call these pivots. And when you look at Ciespace was actually founded originally back in 2007 by Dr. Kenji Shimada as a way for him to commercialize and bring his patented meshing technology called bubble mesh to market. And so he was bringing that to market as a component technology that would be incorporated by other CAE vendors into their end user applications. In 2010, Dr. Shimada basically wanted to start growing Ciespace from being kind of this component supplier into a full end-to-end application provider in the area of pre-processing. So basically, instead of just supplying the engine that goes under the hood of another application, he wanted to supply the whole car. At that time, Ciespace took on some venture funding as a result
he wanted to build the whole car, as in the car being a preprocessor. A full preprocessor, but not a solver or maybe not a post-processor?
Exactly. So he wanted to basically build a pre-processing environment leveraging his meshing technology. Then when the company took on venture funding, a lot of research was done into the market and where it makes sense to invest. They looked at, for instance, some of the trends that were taking place. And one of the trends that was identified was, for instance, the movement towards SaaS and cloud-based applications. They looked at opportunities in the CAE space, and that's really where the shift took place from delivering not just a pre-processing environment that was a traditional desktop client-based architecture, but delivering more of a CAE platform-based approach entirely delivered through the cloud. And I think in a moment we probably want to go into describing what we mean by this CAE platform.
Yeah, so tell me a little bit more about the platform as it stands today, and then what your vision is for it.
Yep, absolutely. So the whole idea, of a platform is, one of the challenges with the platform is that no one buys a platform for the sake of a platform. People buy the platform for the sake of what they can do with it. So what we've done is we've built a platform on top of the cloud for delivering rich, large data engineering applications. And we chose Ciespace CFD as the first product to kind of develop ourselves as an end-to-end CFD application on this platform. In software parlance, we call this eating our own dog food. So basically, the best way to prove that something works is to use it yourself and see how effectively you can deliver an application using your own framework. So we chose CFD as kind of our test case for a few different reasons. One of the reasons was the fact that there is a broadly adopted, extremely powerful open source solver available out there with a large community of users. That's the Openfoam solver. Another reason is that, quite simply, out of the engineering application space, CFD is one of the more challenging ones to build applications for. And the reason for that has to do with the model size or the problem size and data set size that people are dealing with. When we're dealing with the structural world, a few tens of millions of degrees of freedom is typically seen as being a medium to larger size model. In the CFD space, it's not at all unusual to be dealing with models that are pushing north of 100 million to 500 million computational cells in their model size. So we figured if we could tackle this problem of CFD, then that would be a great way to validate this technology and our ability to deliver, render, and interact with these very large data sets in the CAE space completely through the cloud.
Yeah, and Dr. Shimada's original work with Bubble Mesh was sort of targeted at CFD meshing, I think. But, this is getting into the technical weeds a little bit, but I like the story of Bubble Mesh kind of enabling this workflow on your platform, because meshing is one of the roadblocks that stops a lot of people from being successful with CFD. It takes a lot of expertise to get it right. It takes a lot of experience. It takes a lot of black arts and magic it's sometimes. So how does Bubble Mesh enable your platform?
Yeah, so I don't think Bubble Mesh is really an enabling technology to our vision. I think the trajectory the company has followed, that it provided the initial impetus and the initial direction, but I think things have, when we move towards seeing that what we really wanted to do is a platform, an open platform-based approach, that's when things kind of changed a little bit. Now, Bubble Mesh is a very unique meshing technology. It's what we call kind of a physics-based or physical-based mesher rather than a Cartesian or geometry-based mesher. And the way it works is, think about it, it's almost packing a volume with little bubbles and then using the loci or the centroids of those bubbles to basically build the elements from. Traditional meshers either use kind of a Cartesian marching approach, or they use an advancing front approach to create their meshes. And it turns out that this Bubble Mesh allows you to do some really cool things from the standpoint of introducing anisotropy and variable element size and refinement very effectively into even complex geometries. But the whole idea, Jeff, of the platform is that we've got a series of we call them engines inside the product. We've got a geometry engine, a mesh engine, a solver engine, and visualization and results engines. But the way the product has been built and this idea of the platform is that any one of those or all of them can be replaced with either proprietary. So let's say a company, a large enterprise might want to put their own in-house codes into the product. So proprietary, other commercial offerings, academic, or open source codes could replace any one of those engines and basically deliver their application to market using our SaaS-based infrastructure very quickly.
Yeah, so you got this great SaaS-based infrastructure, but I want my listeners to go check out some of the videos on the website and see how modern looking the tool is, or the tool sets are. So the actual user experience today, I think, just from what I've seen, is reasonable. And you're right. A lot of big companies have historically had teams of programmers who are building their own in-house codes. And those codes are fantastic. Some of them are just phenomenal when it comes to the calculation, but boy, are they not pretty to look at. And that's an interesting idea, to be able to, package some of those up and basically deploy them on your platform, maybe bringing them to more people in the company.
That's exactly it. And that's, so we've built Ciespace CFD is a end-to-end CFD solution that's already, like I said, being used by many of our commercial customers. But the vision is to really move forward with this idea of the platform. And the platform makes a huge amount of sense both for large enterprises as well as in the commercial space. Now, in the commercial space, we're all familiar with the handful of the biggest, the big dogs in the CAE world, right? Companies like ANSYS and MSC Software, CD Adapco, ESI Group, that actually is the developer of one of the streams of Openfoam. And what many people don't realize is that in addition to a handful of these very large players, there's literally hundreds of smaller players that tailor to very specific problems that people need to solve. Optical analysis, very specific types of CFD or special chemical mixing processes or combustion processes, so forth. And so one of the things that we're looking to do with the platform-based approach is give all of these other vendors an avenue through which they can bring their products to market to a much broader audience, more easily than they've been able to in the past by leveraging our SaaS infrastructure to bring those to market. Now, go ahead, Jeff.
So you're a little bit like, I'd say, all of my listeners won't get this, but the Salesforce AppExchange, or maybe a little more well-known would be the Android marketplace.
Exactly. That's ultimately the direction that we're looking to be heading. And one of the questions that people ask is why. And I think not only why pursue kind of this marketplace idea like an AppExchange or something, but why go to the cloud at all? And I think that's really where we start to differentiate when you look at why should engineering applications go into the cloud, and does it make sense?
Well, that's a good question, and I've heard the question asked a lot in the last 2 years for sure, and you get some pretty wild answers out there, disparate answers. Some people are totally against it. I know a lot of very large companies, if you talk to them, have no interest in moving to the cloud. Maybe they will in 10 years, but today it's almost a dead wall of silence when you bring it up to them. I think it's a lot more appropriate and accepted by a lot of SMBs out there, small, mid-sized businesses. What say you?
So one of the things that I'd say is, even when we deal with, so let's take a step back. What are the benefits of having an application in the cloud? And then let's take a look at what spaces it applies to, or what market segments. So some of the benefits of being in the cloud are accessibility. You can't beat accessing your data from anywhere in the world or logging into an application just by giving a username and password. We also have the possibility, by being in the cloud, of leveraging and building in some very unique collaboration tools. It's one thing to send, screenshots and PowerPoint slides that have fringe plots on them, but it's another one to be able to, with someone halfway around the world, do real-time collaboration where you're spinning a mesh interactively, highlighting that, hey, these elements look a little bit too big. Can you remesh this and make them smaller here? Or looking at results and explaining to a client that something in a particular region of the model needs to be corrected. Then there's other benefits, such as financial benefits. So things such as paying for the software, for what you use, rather than always paying for it. When you get into these large problems, especially, for instance, with our first application, CFD, the problem you run into is that, if you want to solve a big problem, you might need some serious horsepower, like a 128 core cluster, to address that problem. Well, if you're only solving a problem of that scale a couple times a year, the rest of the year, you're paying for a massive amount of hardware, IT to support it, and huge license costs just to keep that around, even if you're not using it. And this kind of pay for what you use, pay as you go model, dramatically reduces the cost of entry into these technologies. Now, the other part of that question that you asked was this idea of large enterprises versus small and medium businesses. So even large enterprises want to benefit from some of the things that I mentioned, the ability, unparalleled accessibility, the scalability of resources, so forth. The problem is that some of the largest companies, especially companies that are very data sensitive, so let's think about the Raytheons and the Lockheed Martins of the world, they're never going to use a public cloud to do their work. But it's not. But what many of them do want to do is they want to use private clouds. So a private cloud is basically, think of the World Wide Web, but inside your own firewall. So only people logged in from inside your own network have access to it. And so to address that, we're actually working to make our platform available for private cloud installations. And that'll help us deal with, for instance, companies that might have 10 or 20 in-house codes that they've developed over the years, and provide a platform on which they can host those for all their internal use. And then for the small and medium business space, which tends to be a little bit more agile and responsive to adopting newer technologies, they can use what the public cloud instances. And that's kind of the way that we see this moving forward.
Well, one of the other things that we often hear with the cloud is a term that I'm just going to toss out as an inside joke for some of my listeners, for my friend John Chauner. the democratization of CAE. So how does your platform impact getting CAE out farther into the engineering enterprise?
I thought John Chauver was going to throw out the word disenfranchised users or something when he threw out the term democratization. And for those of you out there that have never checked out, there's a great blog called Another Fine Mesh put out by John, and very, very good reading. It should be on your list. So that's a great point, and one that we've given quite a bit of thought to. Here's a question I'll pose to you, Jeff, because you're another kind of industry veteran that probably has more gray hair as a result of being in the space than you like to admit to. Mine's just falling out. But if you go to a company that's got 100 good engineers, mechanical engineers, and how many of those 100 could solve a problem like, let's throw tank sloshing using a generic kind of general purpose CFD code? Out of 100, how many guys could do that?
Tank sloshing that's a pretty tough problem. I think you'd be really lucky if you could get 10.
Yeah. So my gut for that problem would be probably closer to 5%. I think if you're doing a more generic, let's say, internal flow problem, you might be closer to 10. And when you get into structures, you can sometimes squeak up to 15. So if we look at the CAE space over the past, few decades, there have been a few big barriers to more people leveraging these technologies. The first barrier was the fact that back in the 80s, the software simply didn't exist. Now, companies like ANSYS and SRAC and RASNA did a lot of work to make the software, the picks and clicks, easier to use, and kind of basically made that software then accessible. So you're no longer editing an input deck manually. Your UI isn't VI, but you're actually dealing with the GUI. Now, the second thing that kind of had been a barrier to adoption of these tools more broadly was compute horsepower didn't exist, or it was extremely expensive. I remember, in my early days in the space, you want to run problems, you got to shell out for an SGI Indigo 2 or for an Octane, and you're basically talking, a nice luxury car worth of compute power for a single engineer.
Arguably not as fun.
And not arguably, it's definitely not as much fun. And so, those two barriers have now largely been removed. The software now at this point is pretty easy from the standpoint of the picks and clicks. And, the compute horsepower is becoming less and less expensive. But now there's still another barrier that's limiting the spread, or I guess the democratization is the word, of these tools. And that last barrier is the fact that it's not enough to know the picks and clicks. The problem is you need to have the knowledge of how to solve a problem. So, for instance, that tank sloshing problem, it's a problem of, I've got multi-phase flow, so I've got a liquid phase and a gas phase. It's going to be a transient analysis. I have to figure out what the initial conditions are going to be. With CFD codes, I might also have to go in and start tweaking the solver. What are the divergence, convergence schemes, all this other stuff. And bingo, before you know it, you're down to a few engineers out of 100 that actually have the level of knowledge or used codes before or solved that problem before that can actually tackle it. And this is where we see this platform-based approach and the fact that we're in the cloud really being able to provide a significant differentiation as we evolve the platform. And what we're hoping to get to in the not-too-distant future is the ability for not only for companies to publish and host applications on our platform, but imagine an end user creating a workflow, maybe an individual consultant or a consulting firm. Imagine them being able to basically take and publish a workflow they've created, annotated, all the settings are there, everything's ready, up into the cloud. And so instead of going to, for instance, a GrabCAD to grab a specific CAD model, imagine going to Ciespace and looking up, hey, this is the type of problem I'm trying to solve. What are the kind of individual workflows or apps for that problem that exist?
Okay,
and,
so
that's really our vision.
SaaS business model, CAE in the cloud, these are all sexy terms to talk about. But I think what you just said there is probably the most compelling thing from the whole interview here, and really probably the most compelling thing about the core business value you could offer. And that is, if you want engineers, more engineers to take advantage of CAE, you can't, in my opinion, just offer them an easier to use GUI. You have to give them a specialized, what I call an app. I call it appifying CAE. I think that's the way that you get these tools out to a wider audience. And, if we take that CFD example that you mentioned, this tank sloshing, it's not good enough just to say we have a tank sloshing app. I mean, there's different kinds of tank sloshing. It could be, tank sloshing in an automobile's gas tank versus tank sloshing in a milk jug. So we'd have the milk jugifier application. That's the level we need to get to in order to really get it spread.
And that's exactly true. And to add a level of kind of another little editorial on top of that, I came from a large enterprise class software vendor. And one of the things that large enterprise class software vendors always fail at is creating content. The reality is that when a company, think of how many CAD companies out there have tried creating good libraries of parts and so forth. The problem is that you can never keep up. The data, as soon as you create the data, it's going stale, and it's just not going to get out there. And that's really where the idea of kind of community-based content creation starts to make sense. Think Wikipedia versus Encyclopedia Britannica is one example. So, it's not enough to kind of have these apps, but the apps, in my opinion, these need to come from a huge community of users where specialists and people with knowledge in that specific domain are the ones that are creating their own apps for those problem types, because it simply can't be done when one company is creating that themselves, because you'll just never keep up and you'll never get specific enough for it to be really useful. And that's, probably the single biggest differentiable thing between Ciespace's approach and the other companies that are taking platform approaches or SaaS approaches, is this whole idea of an open platform so that other people can be contributing to it rather than us being the ones that are responsible for creating all the content, and be that meshing or solution content or workflows, and hosting them, publishing, and making them available on the system.
Well, John, I'm totally on board with that future vision. You're not there yet today. If you go visit Ciespace, you're looking at the first solution to be offered, which is CFD based on Openfoam, and collaboration as well, I think, is in there, where you can actually do some markup and work with other folks on the same model, and that's important. How can people find out more about it and maybe even try it?
So probably the best place to start is go to our website, ciespace.com. Just like my last name, a lot of people pronounce that different ways, Ciespace, C-Space, or C-Space, whatever. The name, actually, I've heard a few different origins, anything from Carnegie Integrated Engineering, because it came out of Carnegie Mellon, to Computer Integrated Engineering, but the name is what we've got. So take a look at our website, www.ciespace.com. We've got some videos there. We've also got videos up on Vimeo. There's a blog that we keep up to date on the website too. You can check out what I or some of the other folks are writing about. And if you find what we're doing interesting, we're also offering, we do 2-week trials of the product. So it's a quick orientation, and then you're off and running. You've got 20 CPU hours to use, and a 2-week trial that you can try out the solution and see kind of what it looks like. And I think a lot of people are very skeptical, is a CAE application through a web browser even feasible? And frankly, they're pretty shocked. So check out the videos, read a little bit about it. And if you're interested, we'd love to have you sign up for a trial.
Well, there it is. Go give it a shot. And if you like what you see or you don't like what you see, leave some comments in the blog post for this episode, and maybe we'll get a conversation going. John, thanks again for joining the show.
Thanks a lot, Jeff.
That's all for this episode. Thanks for listening to the Life Upfront Engineering Podcast. Visit lifeupfront.com to comment and connect with me on Twitter, Google+, and LinkedIn. Also, you can really help the show by leaving a review on iTunes. Thanks again. Until next time.